Scientific research at the University of Southern California is being conducted on a grand scale to generate discoveries that will change society. One office at USC, the Office of Research and Innovation, is responsible for overseeing and supporting research and innovation across the university. One man, Dr. Ishwar Puri, known as Ish, leads this office. Ish has made it his mission to get to know each of these scientists personally and to understand their work. He accomplishes this by simply having conversations over coffee. These conversations have become known as Coffee with Ish.
So, we'd like to know who you are, what you do. Who is Daniel Lidar? What are his dreams and aspirations? And how are they coming true?
I am a professor of electrical engineering and also chemistry and physics here at USC. My work is on the topic of quantum computing, which is one of the promising ways to revolutionize computing, as we like to say it.
The way information is stored, the way it's processed, it's just completely different from traditional computing, right? So, for example, in traditional computing we have bits. In quantum computing we have qubits, and the amount of information that can be stored in a single qubit is pretty much infinite. The other thing is, how do you process information? We have equivalent processes in quantum gates. They allow a much more efficient way of processing data.
What is quantum mechanics, and how does that lead us to quantum computing?
Yeah, so quantum mechanics is the theory of everything. It is the theory of the universe as we understand it at all scales. And so quantum mechanics is inherently a theory involving probabilities, things happening at random. Nothing is ever truly deterministic.
So we're either here or not. It's a 0 or 1, right? Are we talking, or is it probable that we're not talking?
It's not so clear. In fact, one of the counterintuitive predictions of quantum mechanics is that there is another universe right now in which we're not having this conversation. We're sitting here and maybe we're playing ping pong or something like that, as is known as the multiverse theory.
So are there only 2 of us in that we are here on this universe and another universe, or are there 5 of us?
There are infinitely many possibilities. The conversation we're having right now is happening in one particular branch, and the branching continues to happen all the time. So the universe is, in some sense, splitting all the time. And this is one interpretation of quantum mechanics.
So you or I could be leaving this conversation and inhabiting another universe.
There is a universe in which that is happening.
So either we talk or we don't talk.
Either we talk or we don't talk, or there is some continuum of possibilities in between.
The universe we live in is hard enough to figure out. So there are questions that have been bothering us for years and decades. So we're just trying to work on them. And one way is to go at them directly and just try to make a model of theory that unifies phenomena that we otherwise just understand as separate entities. Sometimes you work on very well-defined small problems. You try to figure them out. And while you're figuring them out, you're making these much larger discoveries, right? So sometimes if you have a more modest mindset and you're working out a problem that might actually look quite technical, sometimes the enlightenment you get when you really understand it is much beyond that little problem.
This gives rise to a whole new world of computational possibilities, because imagine a computer that is operating according to the laws of quantum mechanics. But fundamentally, every time it tries to run a calculation, there's a probability that will give you either the right answer or the wrong answer. So what are you going to do about that if you're trying to build a computer? It sounds like a big problem, but it's also an opportunity, because sometimes trying to take a straight path towards the correct answer is not the most efficient way to do it. Sometimes it actually helps to guess.
What do your colleagues in traditional computer science think about this?
There's a great enthusiasm about the possibility of alternatives to standard computation which could give you answers faster and solve certain problems that you wouldn't be able to solve otherwise.
Some of these algorithms, they can achieve things that are classically not possible at all.
In quantum mechanics, one of the predictions is that particles can, in some sense, literally go through walls that they wouldn't be able to go through because they just don't have enough energy.
Particles only, or collections of? Could we go through walls?
So anything, in principle, could go through a wall, but the probability that you will do so increases the smaller the particle is, and the thinner the wall is and the lower the wall is. But electrons or other fundamental particles do this all the time.
So you can look at the same object, usually microscopic objects like electrons or nuclear particles, in both ways, both as a particle and as a wave. Quantum mechanics allows for that, so that it's a formalism that allows you to interpret these small objects both as a particle and a wave.
You're a scientist and you're also an engineer. There's a thrill of discovery, there's a satisfaction from providing a solution. Tell me how you live your life in that world.
I certainly love the thrill of discovery. I also love seeing things getting built, devices coming out into the real world.
I think of my research as taking part in a big movement, where we're trying to understand how quantum mechanical phenomena occur in our world, how we can make them useful.
This is a hard field.
Yeah, it is not just the pursuit of basic knowledge, pure knowledge. It's also an activity that is now being pursued around the world by governments and universities and companies on a scale that, frankly, I could have never imagined.
I think quantum technology will become dominant this century. It also has so many applications, and we span the full spectrum of quite mathematical, quite theoretical, philosophical to very applied.
Why USC? You could be anywhere.
This is a great university. It's done wonderful things for me personally and for our whole research activity in this area, and there's been a lot of support. But perhaps more importantly, we get really great students that come here who are passionate about this area. And I've had the pleasure and the privilege of working with a lot of these people. A number of enthusiastic young graduate students who apply to our graduate program and who contact me personally and want to become involved in this activity is mind-blowing.
It's just infinite. I know we're part of a big technological revolution at the moment.